Okay, so far we studied corporate governance in the sense of an alignment of interest between the economic agents who are actually making decisions for the firm. So we call them managers, with the interest of investors who actually bring capital, bring funding to the firm. Okay. But there's another aspect of corporate governance, which is also simply the selection of managers, making sure that the managers appointed to run the firm and to make decisions are the ones most able to make these decisions, so as the ones most qualified or most talented. Okay, and so this is the focus of the model by Hermalin in the JF 2005. Okay, so you should read this paper, and I'm going to describe it using the same notations as the author. Okay, so the model is actually pretty simple. And so here the idea is to understand how the board is going to appoint CEOs, but most importantly is going to monitor the performance of CEOs and possibly replace CEOs with someone else. So we have a CEO with ability A, and ability A is unknown, and it's drawn from this distribution. So it's normally distributed with a mean of mu and a variance of 1 over tau. So here tau is the precision of CEO ability. And so first of all, so you're going to appoint the CEO, so you don't know exactly what the ability A of the CEO is. You just know that the expected ability is equal to mu. Okay, but after the CEO is appointed, so you're going to be able to observe the CEO. You're going to be able to monitor the performance of the CEO, even if this doesn't reflect publicly available information. The board will be able to acquire information. And so we're going to assume that the board gets a signal Y about CEO ability, which is informative in the following sense. So the signal is centered on the actual realization of CEO ability, but it is not perfectly informative about CEO ability in the sense that it is a noisy signal, because here you have this noise term with a positive variance 1 over S. Okay. And so this is a signal Y that the CEO, that the board gets. So the board is going to observe the realization of the signal, so the realization Y of Y tilde. And basically, it's only going to observe the signal with some probability, P. Okay, so with probability P, the board observes the realization Y of Y tilde. And with probability 1 minus P, the board does not observe anything. Okay, so the board is not more informed about the CEO's ability at the time of making the termination decision. Okay, so after monitoring, and so monitoring again can be successful with probability P or unsuccessful with probability 1 minus P. But so regardless, after that, the board is going to make the termination decision. So you can terminate the CEO and hire a new CEO with so whose ability will be distributed according to this distribution. Okay, so it has the same precision or variance as the initial CEO's ability. The mean is slightly lower, so mu bar is lower than mu. This is simply reflective of the fact that at first you hired the most qualified person for the job, and only if this person turns out in expectation, right? And only if this person disappoints, will you replace that person with someone else. Okay, so that's the termination decision. And of course, you can decide to retain the current CEO if performance is satisfactory. Okay, and after you've made a termination decision, output X of the firm is realized. And so here, as you can see, output is going to depend on the ability of the CEO in place. Okay, so this will be the ability of the initial CEO if the CEO was retained or reappointed. But this will be the ability of the new CEO if a new CEO was hired at this stage. Okay. But output will not be fully revealing of the CEO's ability. Output will only be a noisy version of the CEO ability because there is some noise epsilon tilde here. Okay. Here, information is symmetric. So everyone knows the same things. There's no effort decision, and the CEO does not take any action. The only thing that matters for the CEO is that his ability can be at different levels. So he's more or less able to manage the firm. Okay, so what is the board's utility? So how is the board making decisions? So the board utility is defined over two things. It's defined over the firm's output, X, and it's a linear function of the firm's output minus the cost of monitoring effort. So here it reflects the fact that getting information about the CEO is costly. Okay, and the more information you get, so the higher P is going to be, the larger the probability that monitoring is going to be successful, the larger the cost of monitoring. That makes sense. And so yes, C prime is positive, so the cost of monitoring is increasing in the quantity of information collected. Okay, so that's for the setup. Huh? So pretty straightforward. So note that there's two decisions in this model. So the first one will be the monitoring decision. So how will the board decide the intensity of monitoring? So the level of P. And the second decision will be the termination decision. Okay, so after monitoring takes place, are you going to retain or terminate the CEO? Okay. So to understand the termination decision, of course, we must understand how the board is going to update its beliefs about the ability of the current CEO after observing a signal, a monitoring signal. Okay, so the unconditional distribution of the signal that we're going to use is, so the signal Y can be decomposed into two terms. So the ability of the CEO plus some noise. This follows from here when we view A as a random variable. So that gives us the unconditional distribution of the signal. And we know that it's going to be normal with the following mean. So here we take the expectation on both sides of this equation. And so the expectation of A, so the expected ability of the initial CEO is equal to mu, right? If you take the expectation on both sides of this equation here, you get that the expectation of A is equal to the expectation of mu plus the expectation of this, which is 0. So this is mu plus the expectation of epsilon y. What's the expectation of epsilon y? It's 0. Okay. So that's why all this here is equal to mu. Okay. What is the variance? So the variance again of the signal. So it is the variance. So again, to make these calculations, you replace the signal by this expression here. We are going to use the fact that y tilde, so I did not write it down here, but y tilde is independent from this random variable, right? So the variance of the sum will simply be equal to the sum of the variances. Now you get the variance of A. Variance of A, simply this, plus the variance of epsilon y. Again, we go back here, epsilon y as this variance, okay? So it's easy, we get this. If we rewrite it, this is also equal to this, And using the same notations as Hermelin in his papers, this is equal to 1 over capital H. Okay. All right, so now, so how do we update beliefs? So we know that these are the formulas that we're going to use for belief updating. If you have two normally distributed variables, X and Y, and you observe the realization of X, then the variable Y will be normally distributed with the following mean and variance. Okay, so we've already studied this before. So let's use these formulas now in the context of our model. And so first of all, so we're going to, so we're of course interested in the distribution of the CEO's ability, right? So we know that it's going to be normal with the following mean and the following variance after we observe a given signal Y. So the expectation of the CEO's ability is the unconditional expectation, so that's equal to mu. We already derived this. Y tilde, so whenever we have Y tilde here in a covariance or a variance, we just replace by its expression from the unconditional distribution, which is equal to this. So that's what I did here. After that, we have the covariance between this and that, but these two variables are independent. So the covariance is 0. We just have it with a covariance between A and A, which is just the variance of A, which is equal to this. And then we have the variance of Y tilde that we already calculated right here. Okay. And then we have the term that I call the surprise. So what is the deviation between the realization of the signal Y and what you expected the signal to be? So we expect the signal to be equal to mu. This is the mu we have here, the expectation of the signal. But the signal realization is, of course, Y. Okay. And so the expectation of the CEO's ability conditional on Y is going to be equal to all this, which I'm going to denote like this. Okay, so now let's move on to the variance. Well, really going to use the same steps, right, with the covariance and the variance. So it's really the same thing. So you obtain this, and if you rearrange, you get that. So try to do it at home. Make sure you find the same expression. So to summarize, conditional on the realization Y of the signal. So if monitoring was successful and you observe a signal Y, the posterior belief of the board is described by a probability distribution. And now the board believes that the ability of the CEO is normally distributed with the following mean and variance. So of course, if Y was greater than you expected it to be, so if this term is positive, then the new mean of the CEO's ability will be larger than its initial mean, its unconditional mean, which was mu. Okay, so that reflects belief updating. And with this variance, right? And so here, in any case, if the signal is informative, this variance is going to be lower than the unconditional variance, which is just 1 over tau. So as long as S is positive, as long as the signal is informative, this variance would be lower than the unconditional variance. Right? It's a measure of the residual uncertainty. And here, so why did I write the mean like this? So this is exactly the same expression as this one. I just rewrote it to make it apparent that the conditional mean is really a weighted average of two things: a weighted average of the initial belief of the board on the CEO's ability. So the unconditional mean of A, which is mu, and of the signal realization Y. Okay, And what are the weights on these two components? Well, the weight on the signal realization will be higher if S is higher. And so S is the precision of the signal. And the weight on the initial ability of the CEO will be higher if there is less uncertainty about the initial CEO's ability, meaning if tau is higher. And when tau is high, the initial distribution of the CEO's ability has a low variance. Okay. And so here, 1 over tau is the variance. And so tau hat, sorry. So 1 over tau hat is the variance. So tau hat is also called the precision. And we know that it's equal to this, which is here. Okay, so this is what we have. And as you can see, so when you have the conditional mean and the conditional variance, the conditional variance does not depend on the realization of the signal, whereas the conditional mean does depend on the realization of the signal. So the signal realization is going to shift the beliefs, but it's not going to shift the precision of these beliefs. So here I took a simple example. When mu is equal to 1, so this is your initial belief about the expected CEO's ability. With a variance of 1, so this is your prior distribution about the CEO's ability. And in both cases, you observe a signal y, which is equal to 2. So the first figure here represents the case of a signal which is informative, but not highly informative. And there's still quite a lot of noise in the signal. And the variance of the signal conditional on the CEO's ability is still pretty high. And so the board is going to shift its belief to the right, but not that much, right? The beliefs are still going to be about here. And it's still going to be substantial uncertainty about the CEO's ability. Now, if we move on to the second case on the right, so now the signal is much more precise, right? So in this case, so there's two consequences. So the first one is that the beliefs of the board are going to move more for a given realization of the signal. It's going to go closer to the signal. So in other words, the signal is going to be more influential when the signal is more precise. And the second consequence, of course, is that the board will have a much more precise idea about the ability of the CEO, in the sense that the conditional variance will be quite low. And the residual uncertainty about the CEO's ability will be pretty low. And the board will have a pretty good idea about the CEO's ability. Okay, so let's draw the consequences of all that for the termination decision. So after this belief updating. So of course, if monitoring is unsuccessful, there's no belief updating, right? Because the board does not observe anything. And then the decision rule is simply for the board to replace the CEO if and only if expected output with the CEO in place, which is mu, is less than expected output with a new CEO, which would be mu bar. But this is never the case because by assumption, we have that mu bar is less than mu. Okay. So now we only get some interesting action if monitoring is successful. So with probability P. So in this case, the board is going to optimally replace the CEO if and only if the expected ability of the CEO after the board has observed the signal, which is equal to this. Remember, this term is from this slide. So if and only if this is less than the expected ability of a new CEO. And so that's just mu bar. So if you just rearrange, and you solve for the value of the signal realization such that you're going to want to replace the CEO. This is going to be the case if and only if the signal realization y is, so how do I get this? So simply I'm going to use the expression for this variable from here, and I'm just going to replace, and I'm going to isolate y. And so I'm going to find that this inequality is satisfied if and only if y is less than this amount, which I'm going to call capital Y. Okay. All right. So in summary, as long as the signal realization is less than capital Y, I'm going to replace the CEO. So if the signal is low, so that's quite disappointing. So I'm going to replace the CEO with someone new. But as long as Y is larger than capital Y, so as long as the signal is sufficiently high, then I'm going to retain the current CEO. So now from the board's perspective, so before the board even engages in monitoring, what is going to be the expected value of the firm, or more precisely, the expected output? Well, so the board is going to keep in mind what it is going to do depending on the realization of the signal. So here we're going to integrate over all possible signal realizations. So we're going to integrate over y. So here we take the ex-ante perspective. So before monitoring, in the case when monitoring is going to be successful. And so we have to take the unconditional distribution of y, because the board does not know anything at this stage. So this is a relevant probability distribution, which we know is normal with a precision of h, which has already been defined right here. Okay, so h is equal to this. And as you can see, this is the unconditional distribution of the signal, which has this variance and therefore a precision of h. Okay. And so you integrate over all the possible values of y, and you keep in mind that when y is sufficiently low, so when y is less than capital Y, you're going to replace the CEO. So then expected output is going to be equal to mu bar. And when y is sufficiently large, so when y is larger than y bar, you're going to keep the existing CEO, and then your expected output will be equal to this, which, as we know, this depends on the realization of y. So the larger y, the larger your signal is, the larger your expected output is expected to be as well. Okay. And so the board knows this, and knowing that, it's going to make its monitoring decision. Okay. And so it's going to maximize over P. So P is really the choice variable from the board's perspective. It's going to maximize expected output, conditional on P, so conditional on the board's information, minus the cost of monitoring, C over P. So here I'm just taking the board's utility function. I'm calculating the expected utility of the board. And I'm optimizing over P, which is what the board chooses. And the board chooses the intensity P of monitoring. So what is the expected output? Well, there's really two cases, right? If monitoring is unsuccessful with probability 1 minus P, in which case you keep the CEO in place, so that has an ability of mu. So this is the mu you get here. And monitoring is successful with probability P, in which case firm value is going to be equal to this in expectation. So the expression here is really expected firm value conditional on successful monitoring. So if you observe a signal. Okay, so this is the expected output minus the cost of monitoring. Okay. Now the nice thing is that we assume that this function was convex. And so this optimization problem has a simple solution, which is described by its first order condition. And so if you just differentiate with respect to P, you just find that the optimal level of monitoring is described by this. Okay, so P star is going to be the optimal level of monitoring that satisfies this equation. So the model of Hermalin is often cited because it represents really the fact that the CEO in this setting really has some option value, right? Why is that? So here I plotted the expected output of the firm as a function of the signal Y. Okay, so if monitoring is successful and if you observe a signal Y. So here I chose some parameters, right? So I set mu is equal to 1, mu bar is 1/2, these variances and so on. If you plug that into this equation, you're going to find that capital Y is equal to 0. Okay, so it means that as long as the signal Y is larger than 0, so you retain the CEO, in which case expected output is linearly increasing in the signal Y that you observe. Why is that? Well, simply because expected output is equal to this, which is linear in Y. But if the signal that you observe, so if Y is less than 0, it's less than capital Y, then you're simply going to hire the next best alternative. So you're going to replace the CEO, and your new CEO will have an expected ability of 1/2, which is the 1/2 you have right here. And so this is for any signal which is less than 0. Okay, and as you can see, so this really looks like an option. Okay, you have very limited downside because worst case scenario, the CEO in place generates a low signal, but then you're going to replace him, so that's fine. And in the best case scenario, the CEO is going to be extremely talented, and you're going to derive the benefits from the CEO's talent. So that's great. Okay, so the CEO is an option. The firm gets all the upside of a talented CEO, but it doesn't really get the downside, at least to the extent that it can monitor and that it can terminate untalented, in expectation, untalented CEOs. And so here in this model, so again, it's very simple, right? The expected output is simply equal to the expected ability of the CEO in place. So it's equal to this if the signal is above the termination threshold, capital Y, and it's equal to the expected ability of an alternative CEO if the signal is less than the termination threshold. Okay, so that's the model of Hermalin in a nutshell. So now, why do we care, and why is this model important? Well, because this paper was able to observe quite a few trends in corporate governance with a very parsimonious model. So let's look at the predictions. So the first one is that the intensity P star of board monitoring, which is here, is decreasing in mu. Okay, decreasing in mu. Well, C prime is increasing because C double prime is positive. And so immediately you can see that P star is decreasing in mu. the idea is that the more talented you expect your initial CEO to be, the less you really need to monitor. Because like, if you have a superstar in expectation, it's quite likely that you're not going to want to replace your superstar. The intensity of board monitoring is also decreasing with tau. Okay, so what is tau? Tau is the precision with which you know the ability of your initial CEO. And so if tau is very high, it means that you're quite confident that your CEO has a level of ability close to mu. Okay. But because mu is better than the ability of your next best option, then this means that most likely you're not going to want to replace your CEO. Okay. So in this case, it means low monitoring. Right? If you know quite precisely the ability of your initial CEO. So if tau is high, means low monitoring. Okay. The second point is that at least, so if you can monitor, so a CEO with uncertain ability is really an option. And this is what we discussed here. And so firms that have the ability to monitor and to gather information about the ability and about the talent of the CEO are going to value uncertainty about CEO ability. So that could be a bit surprising. Maybe you would think that you would value people whose talents are more precisely estimated, but that's not always the case, right? Because here in this model, you can always get rid of people who turn out to be untalented, at least if you receive a negative signal, and you're going to retain the people who turn out to be quite talented. Okay, so in this case, you actually like that there be some variance about the ability of a potential CEO. But if you think about what this means in practice, so when is there a lot of uncertainty about the ability of a potential hire? It's mostly when you are considering outside hires, when you're considering hiring outside the corporation, so someone you don't really know. Okay. And so Hermann is saying that to the extent that firms, the level of monitoring in firms increase, perhaps because boards included more independent directors with more expertise and more ability to terminate CEOs, then so the level of monitoring increase, and then they valued uncertainty about CEO ability even more, which led them to consider outside hires, so to hire from outside the firm. Okay, and then you really have an active market for CEOs. And one last thing is that, so based on this assumption, so if there's more variance, so more uncertainty about the ability of the initial CEO, that is going to increase the probability that the signal Y is going to fall below the termination threshold. So it's quite intuitive. It also makes sense if you do the math. So here we're looking at a document that I shared also on the course website. And this is what we're interested in. And the probability of the signal is lower than the termination threshold. And so this is equal to this, which is less than 1/2 because this term here is negative. Let's get back to the slides. Okay. And so if there's more uncertainty about the ability of the initial CEO, so if 1 over tau increases, so the probability that the signal will be very low increases. Okay, so in turn, this increases the probability of dismissal. that the CEO will be dismissed after a short term in office. But then, so think about the previous point, right? When we said that boards with a strong capacity for monitoring are going to consider outside hires for CEO positions, right? Outside hires, so by definition, have a higher variance of ability, right? You know less about them, meaning that there's a higher variance of their ability. But if that is the case, then there will be a trend towards more outside hires that is going to coincide with also more CEO turnover. So in a sense, firms are really going to take chances with new CEOs, again, because they benefit from the option value that we already discussed. Okay. So just to summarize, greater capacity for monitoring means more outside hires, and more outside hires means more CEO turnover. Okay, so this simple model can actually explain many of these trends in corporate governance. So if you're interested, I actually extended the model of Hermalin with a paper by my co-author published in the JFQA. And our contribution was really to put the model of Hermalin in a market equilibrium with CEO compensation, and not just that, but also the ability for the CEO to get hired by other firms. So you see in the model by Hermalin, the firm was really a monopoly, right? There was only one firm and several potential CEOs. So of course the firm had all the bargaining power. But if you think about it in terms of a market equilibrium, there's really several CEOs and several different firms. And so our point was to say that, well, if a CEO performs very well, and then the beliefs about the CEO's ability are going to increase, maybe the CEO is going to leave the firm. So the fact that the firm benefited fully from the upside was a bit illusory. It's not necessarily going to be the case, because the CEO might simply leave the firm, or at the very least, the CEO is going to have some bargaining power based on the threat that he might be leaving the firm. And so if we take that into consideration, so actually we showed that, of course, depending on the parameters of the model, the firm may instead prefer CEOs with a more precisely estimated ability. So this option value of CEOs, so it can happen, but it's not the only possible outcome. And our model also explains the association between pay for luck and bad corporate governance. And so it was based on a matching model. Okay. All right, but that's it for the Hermalin model. So again, the point here was to take into account boards are concerned about the ability of a CEO to manage the firm, and that this ability is uncertain, but can be more precisely estimated with monitoring.